how to kickstart your business with artificial intelligence. The anatomy of modern AI, understanding its components and capabilities. Module Introduction. In our last module, we learned about AI and how it impacts our daily lives. Now, let's dive into modern AI. We'll explore the basics, including big data and machine learning, to help you get started with understanding this exciting technology. Ready to explore modern AI? We'll start by learning about big data and why it's important for AI. Then we'll discover machine learning, including its different types. What is big data? Let's start with the key concept in modern AI: big data. It refers to extremely large data sets that can't be processed by traditional computing programs. Why is big data important for AI? We'll find out and explore how AI can help us make sense of all that information. Big data comes in three ways: volume, variety, and velocity. This means there's a lot of information from different sources and it's collected quickly. Let's take a closer look. Imagine an airplane's black box, which records everything that happens during a flight. That's big data. We'll explore more examples and learn how big data helps us with AI. Airplanes, like jets and helicopters, create lots of information during flights. This information is called black box data, and it includes things like what the pilots say, how the plane is performing, and sounds from the cockpit. In just half an hour, a single jet can make more than 10 terabytes of this data. Another type of data is stock exchange data, which comes from when people buy and sell shares on the stock market. This information helps people understand how the market is doing and decide where to invest their money. The New York Stock Exchange is a place where people buy and sell stocks. It creates a lot of information every day, called trade data, which is like a huge pile of papers. This pile is so big that it would take more than 1 million floppy disks to hold it all. Another type of big data is called the Internet of Things, or IoT for short. This means that lots of devices like smart home systems, robotic vacuum cleaners, smart TVs, phones, and fitness trackers can all talk to the internet and share information. This helps companies understand how people use their devices and make them even better. We know that big data is lots of information collected from many places. But why is it so important for AI? Well, AI and big data work together like peanut butter and jelly. Without big data, AI wouldn't have anything to learn from, like a teacher with no books. And without AI, all that information would be like a big mess of papers that nobody could make sense of. Thanks to the power of AI, we can use big data to do amazing things in real time. Imagine a computer that can learn from millions of pictures of dogs and then tell you if a new picture is also a dog. That's AI using big data. The more data we have, the smarter AI can become. Artificial intelligence, or AI, is like a really smart computer that can learn things on its own. When we give AI lots of information, like big data, it can become even smarter. This means it can help us do things better and faster, like finding a missing toy in a big pile or predicting the weather. Because of big data, AI has become even more powerful and accurate. We can use it to understand things like what people like to buy or what shows they like to watch. With AI, we can find patterns in the data that would be too hard for humans to see. This helps companies make better decisions and create new things that people will love. AI and big data can do amazing things together. Researchers say that they can do almost 80% of physical work, like building things, and 70% of work that involves using computers to process information. That's like having a robot helper who can do lots of work for you. AI and big data can also help collect information more easily. For example, instead of having people count how many cars drive down a road, a computer can do it much faster and more accurately. This means we can use our time to do other things. These two things, AI and big data, can help make our work easier and faster. They can also help us learn new things and make better decisions. What is machine learning? We've talked about big data, which is like a big pile of information that computers can use to learn. But what about machine learning? This is when computers use big data to learn how to do something, like playing a game or finding a picture of a cat. Machine learning is just one part of something called artificial intelligence, or AI for short. AI is like a big umbrella that covers many things that help computers think and learn like people. It's like having a robot friend who can learn new things and help you do stuff. So, machine learning is a way for computers to use big data to learn how to do things better. And it's just one part of AI, which is all about making computers smarter and more helpful. We talked about AI, which helps computers learn things. But there's another part of AI called machine learning. This is when computers learn by themselves without us telling them exactly what to do. Machine learning is like when you learn how to ride a bike. At first, it might be hard, but after practicing, you get better and better until you can ride without thinking about it. That's what machine learning is like for computers. Machine learning uses different types of computer tricks called algorithms to help computers learn. It's like having a teacher who gives you hints to help you learn. With machine learning, computers can get better at things like recognizing pictures or predicting what will happen next. When computers use machine learning, they need to practice by looking at lots of examples. We call these examples training data. It's like practicing riding a bike by starting with a tricycle and working your way up to a bigger bike. To teach a computer something new, we put the training data into a special computer program called an algorithm. The algorithm is like a set of instructions that tells the computer how to learn from the training data. When the computer finishes learning, it can use what it learned to make predictions about new things. It's like when you practice riding a bike and then can ride without help. With machine learning, the computer can make predictions on its own. When the computer makes a prediction using machine learning, we check to see if it's right. If it is, we use the algorithm and keep making predictions. But if it's wrong, we tell the computer what the right answer is and ask it to try again. The computer keeps practicing until it can make accurate predictions on its own. It's like learning to ride a bike. If you fall off, you get back up and try again until you can ride without falling. This process helps the computer learn more and more over time. With each prediction, the computer gets better and better at making accurate predictions on its own. It's like how you get better at riding a bike with practice. Types of machine learning. Machine learning is like a big toolbox with different tools for different jobs. There are three main types of tools: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is like having a teacher. The computer is given lots of examples of what it should learn, and the teacher tells the computer when it's right or wrong. Unsupervised learning is like exploring on your own. The computer is given data but not told what to do with it. It has to figure out patterns and relationships on its own. Reinforcement learning is like playing a game. The computer gets rewards or punishments for the choices it makes. It learns to make better choices over time to get more rewards and avoid punishments. Each of these tools is good for different jobs. Sometimes we need a teacher, sometimes we need to explore on our own, and sometimes we need to learn by playing a game. Supervised learning is like learning with a teacher. The teacher has a lot of examples of fruits and tells the computer what each fruit is called, like apple, banana, or cherry. The computer uses these examples to learn and understand what makes an apple and a banana. Then, when the computer sees a new fruit, it can tell us what it thinks it is based on what it learned from the teacher. Supervised learning is a way that computers can learn to do things by looking at examples and getting feedback. It's like a teacher giving you examples and telling you if you got the answer right or wrong. For example, if we wanted to teach a computer to recognize different fruits, we would show it pictures of apples, bananas, and cherries and tell it what each one is. The computer would then learn what makes each fruit different and how to recognize them. Once the computer has learned from these examples, we can test it by giving it a new picture and see if it can correctly identify the fruit. There are two types of supervised learning: classification and regression. Classification is when the computer learns to put things into categories like different types of fruits. Regression is when the computer learns to make predictions like how much a house might sell for based on its features. When we use machine learning, we can either try to predict a category or a real value. When we want to predict a category, like whether something is an apple or banana, it is called a classification problem. When we want to predict a real value, like how much something weighs or how much money we need, it is called a regression problem. Now we talk about unsupervised learning. It's different from supervised learning because there are no labels on the data. In unsupervised learning, the computer is given a lot of data and it tries to make sense of it on its own. It tries to group similar data together or cluster them. After that, a human can come in and look at the organized data to see if it makes sense. Imagine you have a bunch of toys with no labels. You can give them to a computer program and it will group similar toys together based on their colors, shapes, or sizes. It may put all the yellow toys in one group or all the round toys in another. Then, you can come in and look at the groups and see if they make sense to you. In unsupervised learning, the computer is given a lot of data, but there are no labels or categories assigned to it. The computer has to find similarities and patterns on its own and group the data accordingly. It's like sorting a bunch of different colored marbles without knowing what colors there are. The computer uses various techniques to discover the similarities and differences between the marbles and groups them accordingly. This can be helpful for finding patterns in large amounts of data that might not be immediately obvious to humans. Reinforcement learning is a type of machine learning where the computer learns by trial and error. It's like how you learn to ride a bike by trying it out and getting feedback from your parents or teachers. In reinforcement learning, the computer tries out different actions and receives feedback in the form of rewards or punishments. Based on this feedback, the computer adjusts its actions and learns to make better decisions over time. Reinforcement learning is like a video game where a player is trying to win by completing levels. The player starts out not knowing how to win and tries different things until they figure out what works. In reinforcement learning, the player is the machine learning model and the game is the environment it's in. The model takes actions in the environment and gets a reward or punishment based on whether the action was good or bad. It uses this feedback to figure out which actions are best to take in different situations. Over time, the model gets better at making decisions and completing tasks in the environment. Reinforcement learning is like when you're learning to ride a bike. At first, you don't know what to do, so you make mistakes and fall down. But every time you try again, you learn something new about how to balance and pedal. Eventually, you get better and better until you can ride without falling. In reinforcement learning, a computer program called an agent is like you riding the bike. It tries different actions in an environment and gets feedback in the form of rewards or punishments. The agent uses this feedback to learn what actions are good or bad, and it tries to get more rewards and avoid punishments. Over time, the agent gets better at making decisions and taking actions that lead to more rewards. Let's wrap it up for now. We'll bring you more informative content in our next video. If you have any questions, please leave them in the comments below. And don't forget to subscribe and share this video. Thank you for watching.